Hi, Al Williams here. Well, I finally did it. I took my 1802 Uno code, which was the code that runs on an Arduino Uno and drives a KIMUno Uno board to make it think that it's a COSMAC ELF 1802. And I pulled out all the hardware stuff, so all the switches and LEDs and stuff, because I wanted to move it into a Blackpill. And I'm going to show you that now. So I'm going to hit the reset button. This has a bootloader on it, so I've got to make sure the bootloader is off, and I'm going to hit the reset button. And you'll see it says wait, ready, auto start, so it's actually going to automatically boot a ROM. The old one had 1K of RAM and a small amount of ROM. This has 32K of RAM and 32K of ROM, and it emulates having a hardware UART, so you can see we're at 9600 baud. This is the excellent spare time gizmos ROM in all its glory. I did rebuild this, so it's not the complete standard ROM in that it's got basic, fourth, the assembler, the visual debugger, and it does not have all the, VT100, the Pixie graphics, the disk drive stuff. All of that's gone to make room. And it pretty much works the way you expect. So, for example, if I were to say that I want to show the memory, you can see I've got quite a bit free. If you want to show the data page, you can do that. You notice it's very fast. Now, if I go to basic, I've got a couple of options here. I can actually load things using X modem, and that works. I can load things using the method I usually use to load ASCII text files using my paste downloaders. You don't really have to do that because the UART here is snappy enough that you can just paste your text right into this window. So let's see, how do I want to do that? I'm going to do it the way I normally do it. I'm going to pick up ELF2K Bass, and let's see, for my file, I'm going to see if I can remember how to get there. Projects, embedded, 1802, 1802 home, QBlink Bass. Okay, so you can see it just ran right through it and loaded up all that text. And there it is. Now I could have just as easily saved this as a binary file and Xmodemed it over, and that would in fact work. This is a cute little program. I'm not going to run it, but it would work, where it makes a little machine language program, puts it into a variable, and then actually calls it a couple of times to turn on and off the LED, and just a little delay routine. So it's a good example of how to do that. The fourth is my enhanced fourth. It's from Mike Riley originally with Glenn Jolly's additions, and then I made some more additions. So if you type list for that, you can see there's not much in there now, but if I B-load it and list it, there's plenty of things in there. So, this is pretty full-featured. It works just like my actual hardware, except faster with the 9600 baud terminal. And then on top of that, you've got a clock speed of somewhere around 80 or 90 megahertz. Now, of course, the emulation eats up a lot of that, but if I do a test mem, for example, that pretty much runs about, I'd say, 10 or 15% faster than my actual membership card running at something like 1.8 megahertz. So roughly like a 2 megahertz 1802. There is one little interesting feature. Whoops, I'm in the wrong words here. One interesting little feature here is there's a complete meta monitor, just like in the 1802 Uno, and the only problem is with no front panel anymore, it's hard to get into that. You can turn off the auto boot, and then you've got the serial front panel just like you did before, but it turns out the spare time gizmo ROM, when it detects the type of CPU it has, it uses an illegal instruction. And so that's going to trigger a breakpoint into my monitor. So you can do lots of things here, like if you want to look at memory at, say, location 100, or if you wanted to set memory at 110, for example. And it turns out there's a bunch of zeros in there. I just put some more zeros, but You get the idea. You can actually set up to 16 breakpoints, and these breakpoints can even be in ROM because they're not really setting breakpoints the way you think of them. It's actually saying, well, there's that address. I'm going to do that. What else can you do here? You can single step. You can do input and output, and you can also just look at all the registers, for example. And you can modify them too. So like if I'd wanted to change R5, I could say R5 equals something. In this particular case, I don't want to do that. So the problem is now is I'm stuck. You notice P is 3 and 88ED. Actually, if we do mem 8BED, you'll see, oh shoot, that was too many. Oh, that's even worse. Well, anyway, you get the idea. But the problem is there's too many, there's two illegal instructions here. So what you're going to have to do is do continue, which is then going to put us at the next location, and continue again. And then it says, oh, you have a CDP 1802. But if you're trying to debug something, it's really handy to be able to jump into that monitor, set a breakpoint somewhere in ROM, and then go about your business. Start basic, start fourth, whatever, and you can actually have it trap. You'll need to look at the listing files to figure out where to do that. But it's pretty functional. And in fact, you know, once I got it working to a certain point, it was very helpful in debugging itself. So lightly tested, although everything seems to work really well. You've got the excellent visual debugger, which at 9600 baud is quite snappy. And let's see, the other thing I would show you is if you do bring up the monitor again, you can send commands to the fake front panel by using the period. So for example, on the fake front panel, if you want to see the displays, the LED displays that don't exist in this version, use the exclamation point. So dot exclamation point will show us the address LEDs are at FFBF and the data address or the data LEDs are at 00. And there's a bunch of different commands like that that you can use to reset the processor, set the toggle switches for input, things like that. The other thing that probably is self-evident from this, but maybe not, is there's a complete BIOS implementation in here. And it's kind of funny, the ROM has a BIOS implementation in it too, but of course it's for specific hardware that this isn't actually the hardware. So just like the breakpoints aren't really in code, a lot of the key BIOS calls get intercepted, and the emulation just does them and works through with the serial port or whatever else needs to be done. It's a very powerful technique. However, if you wind up somewhere that's not a BIOS entry point in the ROM, like something I didn't implement, or maybe you've got some other ROM, it will run out of the ROM if that's what it takes. And so some of them are redundant. Like for example, you can remove the code that inputs the line and, you know, handles backspace and return and control C and all that, because the ROM code is perfectly fine because it calls other ROM functions to do the keyboard reading, and those are emulated. But I left it in. That's a vestige from when it didn't have BIOS in ROM, that the BIOS emulation was all the BIOS. So it's pretty cool. The only thing that I haven't been able to figure out how to make work well is you notice it says break, interrupt execution of long command. Like for example, if you're doing a test of RAM, and that I can't detect a break. I can send a break on the terminal, but I can't really detect it. I had thought about perhaps rewriting it so that it like inputs a character ahead and holds on to it, and if it sees a control C, it would generate a fake break. I don't know. It doesn't seem worth it. You know, if you really need to do it that bad, you can just hit the reset button, and that's generally adequate. So anyway, it's pretty cool for a couple of dollars worth of Blackpill board, nothing hooked up to it outside of a USB-C cable, and you've basically got a nice 32K RAM, 32K ROM, COSMAC ELF with all the fixins, serial port, and you know, no disk drive, not yet anyway. There's about half the flash in the processor is left. So it would certainly be possible to interface an SD card to it. Oscar has the 1861 emulation code that could be put in here to drive an OLED. I've thought about having banked ROMs where you could at least in the monitor say, well, I want to switch in, you know, for the spare time Gizmos ROM, I want to switch in another ROM or a test ROM. But I haven't done any of those things yet and may not. Anyway, I hope you enjoy playing with it. You can find it all on GitHub. I'll leave links to everything in the descriptions. Thanks for watching.